Okay, this is the P1 paper from January 2024. It's question number 5, and as you can see as I move it up and down, this is a straight line graphs question. Unusually, they've actually given me the diagram, and then they're going to ask me various different parts to it. So let's have a look at it. It says we've got straight line L1 shown in the figure, and that passes through the points -2, 9, and the other point is 10, 6. So I'm going to put those on my diagram. So that's -2, 9. And this point over here is 10, 6. And the first thing it asks me to do is to find the equation of L1. I know how to do that, so I won't bother reading the rest of the question as of yet. Let's just jump straight into this part. So for part A, what I need to do first of all is to just work out the gradient of PQ. And that's going to be using y2 minus y1 over x2 minus x1. Put in all the information we've got. We've got 6 minus 9 over, just be careful about the order of these things, 10 minus minus 2. So that works out to be -3 over 12 or -1/4. And then for the equation of L1, I'm going to use y minus y1 equals mx minus x1. So let me make it clear to the examiner what I'm doing. I'm going to use the point x1 is 10 and y1 is 6. We know the gradient, we've just worked it out, is equal to -1/4. And so if I just stick everything into that now, I'm going to get y minus 6 equals -1/4 x minus 10. Multiply everything by 4. 4y minus... Oh, actually, no, don't do that. Sorry, that's my standard thing to do. Sorry, let's just go back and have a look. They actually want it in the form y equals mx plus c. So just purely because they want it like that, it's easier this time then to say y minus 6 is -1/4 x plus 10 over 4, which is 5 over 2. And then to just take the 6 over. So if we take the 6 over to the other side, we get y equals -1/4 x plus 17 over 2. And I've got it in the format that I wanted, which is y equals mx plus c. Then what it says is we've got the straight line L2, which is passes through the origin and is perpendicular to L1. So we know that this is a right angle, and if we know it's a right angle, then what we do is we know stuff about the gradient. So let's make that clear to the examiner. For part B, for L2, m is simply -1 over -1/4, but easier to just say that. M is equal to 4, and we want the equation of the straight line, but it's y equals mx plus c, and there is no plus c. There's just y equals mx, so y is simply going to equal to 4x, and that's the equation for L2. Why am I doing that? Because I want to find where the two lines meet, and they're going to meet at point R up here. So for point R, we just want to equate the two equations. So for point R, we've got y equals 4x is one of, but we've got these two. Basically, y equals 4x, and y equals -1/4 x plus 17 over 2. We're going to put them equal to each other. So we're going to say 4x equals -1/4 x plus 17 over 2, which means 4 1/4 x is equal to 17 over 2. So x is that one divided by that one. It actually works out to be equal to 2. And if x is equal to 2, in order to work out the y coordinate, I'm going to use y equals 4x, so y equals 4 lots of 2, y equal to 8. So R is the point, 2, 8. And let's go back and put that on our diagram now. We know this is the point 2, 8 on here. So part B done, and then part C. Really standard one, find the exact area of the triangle OPQ. Remember at the end to make sure it is an exact value if it's a surd, which is probably the most likely thing. Find the exact area of the triangle OPQ. So OPQ is this triangle here. And in order to work out the area of this triangle, what I need is the base and the height. The fact that that's 90 degrees in there, which is why I put it on my diagram just to remind myself, means that this is a relatively easy thing to work out. Let's make it clear for the examiner what I'm going to be doing. So say area of triangle is going to be equal to half base times height, which is going to be a half OR times OQ. Let's work out those two. OR then, we'll just talk about for both of them, but OR is the length of this one. That's just going to be using Pythagoras, y2 minus y1 squared, x2 minus x1 squared. The same when I'm working out PQ. PQ is just going to be using exactly the same formula to work out the length of the line. So I say we'll do OR first. That should be PQ, sorry, not OQ. That should be PQ up there. So OR is just going to be the square root of 2 minus 0 squared and 8 minus 0 squared. Well, that's just going to give me that, isn't it? That works out to be equal to root 68. Leave it in terms of surds until we finish the whole thing. And then PQ is going to be the square root of, using the same formula, I'm using x2 minus x1 squared and y2 minus y1 squared. We've actually got the coordinates there being square root of 10 minus 2 squared and 6 minus 9 squared. Chuck all that in. That works out to be square root of 153. And then the area of the triangle is just half root 68 root 153. And then they want that as an, actually it doesn't work out to be a surd, it works out to be exact value there, which is even more convincing that I've actually got the answer right. If I get something like that, then you think, yeah, I've definitely got that part right. So as we go back, go through that. Relatively standard straight line graph question, working out a couple of lines, working out point of intersection, and then working out the area of the triangle. Hopefully that all makes sense to everybody.